So this video is going to be aimed at MightyMeat.
MightyMeat.
Okay, so in this video, MightyMeat, I am going to blow your mind, man. I'm going to blow your mind. Okay, so no, I'm not going to do that. But what I do hope to do is I do hope to open up people's minds to different ideas and to really make people think about what's actually going on here. So this video is all going to be about a sort of an unexplained phenomenon. Although some people think they've explained it, I don't particularly buy their explanation, and I'll explain that in a bit. But it's all about massive areas of sort of rock from the surface, from the crust, that have been subducted, pulled down into the mantle of the Earth.
I don't like it.
So if we look here, we've got the crust, and then we get into the mantle, which I believe is made up of an upper and lower mantle before you start getting to the outer and inner core. And there's been a discovery. So there's been a discovery that there are these big areas of rock that have been pulled down into the mantle that are still actually at different temperature, a fair bit cooler than the rest of the mantle around them.
Why am I so cold?
So, MightyMeat, if you're anything like me, and I think that you are in some ways, you'll be eternally curious about the universe, and in particular the mysteries and the unsolved things of the universe. And I believe this discovery was 2018, so it's quite recent. When I was on a recent live stream with MightyMeat, I broached this subject and he hadn't heard of what I was talking about. And I wasn't entirely sure myself, so I thought rather than make a fool of myself and just reiterate some kind of thing that I'd heard, I thought it would be best to research it a little bit first and make sure that what I was saying was actually correct. And I wasn't just echoing something that I'd heard and just echoing a claim without sort of some kind of investigation. So the outline of this video is I'm going to briefly talk about the discovery, and then I'm going to give my take on it, and then I'm going to sort of open that up to MightyMeat if he's got a rebuttal or if he's got a different opinion on it, which I think that he might, and that's all good. But I would like to hear his take on things. First of all, I've just noticed here on this page about the mantle. Let's just have a quick look about the temperatures. So it says that in the mantle, it says the temperature there varies between 1,600 degrees Fahrenheit at the upper part and up to 4,000 degrees Fahrenheit near the bottom part of the mantle. So it's pretty hot, whichever way you look at it. Fire. Ooh. Yeah, not a place I want to be. Since the 1990s, cross-section images of mantle tomography have shown visible slabs of oceanic lithosphere, which includes oceanic crust, descending hundreds of miles beneath the ocean trenches into subduction zones. These descending plates have been imaged all the way down to the top of the Earth's outer core and are composed of cold, brittle, dense rock about 62 miles thick. Researchers from the University of Colorado recently reported finding that some of the subducted slabs stagnate at depths of around about 416 miles to 620 miles and appear to travel horizontally. Publishing in Nature Geoscience, Wei Mao and his co-author Shiji Zhong present seismic tomography that show descending plates beneath the Honshu and northern Mariana subduction zones in the western Pacific. The plates stop in the mantle transition zone and move horizontally for more than 930 miles to the west beneath East Asia. Their research goal was to determine why some slabs extend to the core while others stop descending part way through the mantle and move horizontally. Mao and Zong concluded that mineral phase change from increasing temperatures and pressure in the mantle transition zone is likely responsible, stating, "We demonstrate that the observed stagnant slabs in the transition zone and other slab structures in the lower mantle can be explained by the presence of a thin, weak layer at the phase change boundary that was suggested by mineral physics and geoid modeling studies." The authors added that these stagnant plates seem to be a recent phenomenon, all occurring within the last 20 to 30 million years. Recent? Okay, apologies. I was supposed to just read this all the way through. I'll try. My bad. But if these subducted slabs are really many millions of years old, why do they still show such prominent temperature anomalies? All of the images of the subducted slabs show consistently cooler rock surrounded by extremely hot mantle, even after traveling more than 930 miles right through the mantle itself. These rock slabs appear to be at least 1,000 degrees Celsius cooler than the surrounding mantle material at these depths, based on their density.
Why am I so cold? It's been 20 million years.
And a bigger problem was never addressed in the paper. How do the cold slabs that extend down to the base of the mantle at the core boundary remain cold after 30 to 50 million years or more? At the sluggish subduction rates that secular scientists envision, these lithosphere slabs have to travel 1,800 miles to reach the base of the mantle, where the temperature is even hotter, around about 3,500 degrees Celsius or over 6,300 degrees Fahrenheit. So here, just for a few seconds, I'll just show here's just the image itself. So we've got this blue section here going down, and it's the P-wave tomography under Tonga Trench, Pacific Ocean. The blue shows the colder ocean lithosphere descending down into the mantle to a depth of nearly 435 miles. The white dots represent earthquake foci. I guess that means the epicenters of various earthquakes. I'd have to look that up. I've not come across that particular term before. But as you can see here, this goes down pretty deep because we as humans, we've only ever actually managed to dig down about 6 miles. It was about our maximum. The Americans and the Russians, I think it was in the 60s, had a kind of like a contest to see who could drill the deepest. And about 6 miles down, I believe, is about as far as we can go before the drill bits just keep melting, regardless of what type of metal we use. So this is stuff that nobody's ever seen, but we know this from bouncing these various types of waves through the Earth and then using modeling to recreate. We can get a general idea of what's going on at these depths using that technology. So here's another article about the same type of thing. I'm just going to, again, just read through this one. Researchers at CU Boulder, which I think is in Colorado, report that they may have solved a geophysical mystery, pinning down the likely cause of a phenomenon that resembles a wrench in the engine of the planet. In a study published today in Nature Geoscience, and I've just popped in there October 2018 because I believe that's when the study was published originally. The team explored the physics of stagnant slabs. These geophysical oddities form when huge chunks of Earth's oceanic plates are forced deep underground at the edges of certain continental plates. The chunks sink down into the Earth's interior for hundreds of miles until they suddenly, and for reasons scientists can't explain, stop like a stalled car. CU Boulder's Wei Mao and Shiji Zong, however, may have found the reason for the halt. Using computer simulations, the researchers examined a series of stagnant slabs in the Pacific Ocean near Japan and the Philippines. They discovered that these cold rocks seem to be sliding on a thin layer of weak material lying at the boundary of the planet's upper and lower mantle, roughly 410 miles below the surface. And the stoppage is likely temporary. Although we see these slabs stagnate, they are fairly recent phenomena, probably happening in the last 20 million years, said Zong, a co-author of the new study and professor of CU Boulder's Department of Physics. And so here again, we just have some more imagery. So a graphic of stagnant slabs under the Japanese island of Honshu at the top and Mariana Trench at the bottom, using seismic data to the left and computer simulations to the right. Stagnant slabs in blue plunge down to the border between the upper and lower mantle, then screech to a stop. So 2018 Nature Geoscience. Okay, so there's a couple of articles there from two different sort of sources, but both citing this study, this 2018 study in Nature Geoscience. So it seems that Shiji Zong seems to think that this was recent and only happened in the last 20 million years or so. Recent? So, in summary, we have only in certain areas of the world, or only one particular place, it seems, where the rock is pulled under and subducted into the mantle. Only one area where the rock still remains cool, or cooler, I should say, to the mantle around it. It is very strange. Now, in my mind, technically, I think it should have melted already and been the same temperature as the rest of the mantle around it. But I do get the concept that this takes time, and particularly if it's a large chunk of rock, it's going to take longer. In the same sense that when you have an ice cube, it'll melt quicker than a larger block of ice. And you may have the same volume of ice, but if let's say you have, I don't know, 2 kilos of ice, and one part of that is just one big block, and then next to it you have, again, 2 kilos worth of ice, the same mass of ice, but it's split up into, say, 20 smaller pieces, and you leave them in the same temperature. Obviously, the smaller ice cube type chunks are going to melt quicker than the other one because there's more surface area. The lump that holds together is going to retain its ability to stay as ice for longer. And so I understand how that concept would work with the rock as well. That's the cooler rock that's in the mantle. If you've got a big chunk, and I think it said it was like 63 miles thick or something like that, they calculate. Um, yeah, that's going to take a bit longer to melt. It's going to take a bit longer to get to the rest of the mantle around it and melted properly. But 20 million years, though, 20 million years? I could be wrong. Maybe that's correct, but I'm just doubting that for a minute. Now, a lot of my doubt comes from my own personal beliefs and bias, which I will freely admit. And I personally believe that what happened here was that a certain event happened around about 4,500 years ago. And at that point, I think that's when these large chunks of rock were pulled down into the earth below. In my opinion, that's why I think there's still a temperature difference there where we would usually expect to see this melted and at the same temperature as the surrounding mantle. Now, I'm always open to being wrong, so maybe there is a mathematical formula that can be used to calculate the rate of the melt, how long that particular type of rock takes to melt. And if that's the case, then so be it. But I don't know the mathematics about the surface area and all that kind of stuff and how long it takes for that type of rock to melt. My gut instinct just tells me, though, that if there was 20 million years, I think this whole thing would have been melted. I think what we're seeing can't really be explained by what they're saying. And hey, maybe I'm wrong, and Mighty Meat, you might have a completely different take on this. Maybe you'll know how to work out the maths of the rock melting rate at various temperatures. I don't know, and I guess that would be one way to try and figure that out. But the guys who did this study in 2018, they admitted themselves that it causes a bit of an issue, like a bit of a mystery for to try and solve. And they admit that they were basing things on hypotheticals. And I noticed when I was reading those articles that it's actually based on modeling, computer modeling, their sort of theory that it's been about 20 to 30 million years. I mean, how they get to these numbers, I have no idea. And I'm not going to try and convince you either way because I don't have the data. I'm just throwing up a good old X to doubt on this one. And again, my own personal beliefs, there are many other things like this which make me doubt what we're told about the age of the Earth. Some people just think I'm completely crazy for that, but I look at it actually from a scientific point of view, and there are certain things about the Earth and things in it that just don't seem to make sense and throw up that extra doubt about the narrative that we just get told. My philosophy when it comes to scientific things is to basically never dismiss a theory without investigation, no matter how wild it might seem. And I think that's a healthy way to look at science because even what people think to be settled science should always be something that you can question. And if there's new information comes to light, we should always be open-minded enough to look at things and say, did we get this wrong here? Is there actually a different explanation? There are some what are known as pure sciences. Well, the only one that I know of is mathematics. 2 plus 2 will always equal 4, despite what some people might tell you. So, Mighty Meat, just to recap, this is the subject of these large portions of rock which seem to be at an incorrect temperature for what you would expect in the mantle of the Earth. It seems to be a recent discovery, I think 2018. Obviously, different people are going to have different takes on how they think it happened. Now, I think you can guess my theory based on my beliefs, but I'm not here to try and push that on anybody. I just find it an interesting subject. It just seems to be a bit of an odd phenomenon, another unknown, another mystery. And these are the kind of things that get my brain ticking. And I think Mighty Meat might also get your brain ticking too. So I hope you get a chance to do a little bit of research on this subject yourself and come at me, bro. What have you got? Any new information? Any theories of your own? Do you go along with this Wei and Zong guy? I'm terrible with names. Apologies about that. Wei Mao and Shi Ji Zong. Yeah, do you agree with them? Do you have your own theory? Let me know, mate. I'd be interested to hear your thoughts.
Why am I so cold, man?